Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about hidden truth of hydrogen. So let's dive deep into it. And people keep asking about it. So you have to understand one core aspect of humanity itself, that any job, no matter which profession, no matter which field you do, 80% of it is directly dealing with people. That's it. It does not matter whether you are a celebrity or a programmer. At the end of the day, that's all there is to it. So what does that mean? That simply means to understand something, sometimes you have to understand the human side rather than the scientific side. Scientific side is kind of easy, but the human side is the messy part. So what does that mean? That means we have some limitations, and if you do not understand those limitations, you can be blindsided by them. So every human suffers from one primary limit. You, I, every Tom, Dick and Harry. It's out of sight, out of mind. Meaning there will be boatload of activists. They are like, no to child labor, no to this and all that. But they will happily, without even a single second of thought, will buy a product made in China. And even though China is employing 14, 15-year-old boys, or sometimes like flat out kids to do their stuff, because again, out of sight, out of mind. If it's happening in their country, they will be outraged about it and they will try to stop it simply because they can see it. But once it's out of sight, it does not matter. And we all have limited attention. What does that mean? That simply means, think of it this way. This year, not this year, as in like 2022, a war started. We got bored of it. Like, it does not even make news anymore, even though that war has been going for one whole year and is the highest close proxy war that we ever had, where two sides of almost equal caliber are going against each other. Most of the time it's like very superior force against very inferior force, or something like that. After World War II, that never happened, where you had like two almost equal level going against each other, except nukes are like one-sided, but that's happening. We are bored of it. So why is that? Well, again, that's a side effect of human evolution. Our evolution was specifically designed to run on as minimal as possible, meaning consume as less energy as possible. So this puppy, the brain, even though it has a lot of horsepower, majority of the time the horsepower is always offline. It does that. It's inherently designed to, or its hardware is designed that way. So you have to actively put effort into yourself in order to unlock the brain and be like, hey, can you actually work? So we take shortcuts, and that's what we mean, limited attention. Meaning, even if you have the wisdom and processing power to actually solve a problem, if it's outside of your attention, meaning your brain is like, okay, now I'm going to low energy mode, it will just slide right by you. And that's why we have a saying, the devil is in the detail. Meaning, if you're not actively crunching through details, many things that are idiotically horrible can just fly right through you, and you will be surprised, like, how the heck we messed it up this way. The devil is in the detail. That's why I always go for the details. And scammers knows this. Like, every scammer, whether they are from good intention or the bad intention, they know it, that you have attention limitation, and they know that you think yourself so high that you will never pay attention to it. So they are like, they will exploit it. So there are certain red flags. Red flags, one is argument from authority, meaning rather than giving you data, mathematics, science and all that jazz, they will give you names. And you can see that even in Hollywood, if there is a bad movie, generally the movie trailer will start from the makers or from the directors or from this and that, because they movie is bad. If the movie is good, they rarely, or if ever, they will ever say like, oh, like, this movie it made by this or that. So it's one of those things that you have to understand. Argument from authority means a red flag. 99.999% of the time, it's a bad thing. And the only way you can basically save yourself is basically vigilance. Because think of it this way. You may be like, hey, I'm driving a diesel car, and you feel ugly simply because everybody's like, oh, you are polluting and all that. Yes, you switch to electric. But again, you did not pay attention to it, and out of sight, out of mind, you are now consuming far more coal, and that coal is polluting more compared to if you were just using the diesel. So you're literally causing more harm, but you are feeling, good, simply because out of sight, out of mind. And many times, like, what if we do it hydrogen? It's like majority of the hydrogen that is cheap enough to actually use generally comes from natural gas well. And from an energy point of view, it would have been flat out far more practical to just use the CH4 rather than H2. So that's the whole point. That's the limitation. And this is a very good meme about it. It's like fully read terms and condition before applying. Well, ain't nobody got time for that. That's you, me, and everybody. So this is the inherent limitation of it. So if you ever detect something that's like feels off, and people are using basically argument from authority, apply some breaks and be mindful. Devil is in the details. So if they are hiding details, generally there is something bad there. Generally, not all the time, but generally. So hydrogen is one of those things that is like flat out. I cannot believe how many people are just like, oh, hydrogen this, hydrogen that. Is like, it just does not have the density. Like, look at it at a periodic table, where the heck it is. Like now I want to give you real world mathematical data. So Airbus A380, it's a big ass plane. Now benefit of big ass plane is that it has 4 engine. Now benefit of 4 engine is that you can tamper with 1 engine without risking the safety of the flight and the crew. So what does that mean? That simply means if you are designing a new fan blade and you want to test it, you will test it on a 4 engine jumbo jet. So you can do whatever you want. Even if that engine goes boom, there is a 99% of the chance you can safely land the aircraft without risking any further damage. That's why people love to experiment on giant crafts. Here's the it has been done. Like if you new turbine blade, new whole engine, new this or that, that's common. That's how aviation works. So why the heck in Airbus A380, which is a big ass plane which has 1 engine to sacrifice, they are putting a tiny pylon and putting an even tinier engine with a huge ass tank? So to give you a context, what kind of tiny engine we are talking about? We are talking about General Electric Passport engine. Now this puppy goes into Bombardier private jets. That puppy barely has capacity of 25 people. Compared to this puppy, Airbus A380, that has 500 plus passenger capacity. Be mindful, the passenger capacity is around 800. They never pack it to that much. Then the economic class does not make that much profit. So they are like, lower layer is economic, our layer is executive class, so to say. So that's why that number is only 500. But why the heck you are testing on like, such a tiny engine or such a giant plane? Because 4 tanks of liquid hydrogen, they are like 4 tanks of liquid hydrogen. Again, go to Airbus site, you will find it yourself. Is that they're going to keep saying 100 kilograms of liquid hydrogen, 4 tanks of that, basically 4 multiplied by, 100 kilograms. Why they are talking in kilograms? In a liquid sense, why the heck they are talking about in kilograms? Because again, people will trick you by saying hydrogen has energy because it has like, 130 megajoule per kilogram. That means nothing. Now, here's a real world reality of it. That 100 kilogram, if you translate it into liters, meaning how much volume it's consuming inside that plane, that translates to 1.4 k kiloliters. What does that mean? That simply means 1400 liters. You need 1400 liters just to get 100 kilograms. That's the part. Liquid hydrogen is very low density. That's why when Saturn V was built, it has a huge tank. Like oxygen tank was this tiny, hydrogen tank was this huge. So again, hydrogen is very, very low density, even in liquid form. That's why I keep talking about megajoule per liter rather than megajoule per kilogram. And you have 4 of it. So what does that mean? That simply means if you have basically jet propellant, you have 5.6 kiloliters of jet propellant 1, which will give you at worst case scenario 33 megajoule per liter. And if you directly replace that, like this tank capacity, you replaced it with rather than jet propellant, you put liquid hydrogen there, which they are putting, that gives you 10 megajoule per liter upper maximum. So you can see directly that there is a 3x difference. What does that actually mean? If that's just a difference, what does it mean? Jet engine's thermal efficiency is around 30%, meaning if your fuel has this sort of energy, let's say 30 megajoule, you're only going to get around actual oomph, actual push on your system for roughly more or less around 10 megajoule. So what does that mean? That simply means if you are buying a jet engine, which mindful at this point in time, majority of actual large commercial jet systems, they are above 30%, above all the time. And if you have that, like let's say a system that has more than 30% thermal efficiency, that means from liquid hydrogen point of view, you have to extract 99% energy in order to come close to 30%. The moment you cross that barrier, which mind you, the bigger the engine, more likely it is it's crossing that, yeah, you're going to run out of energy in liquid hydrogen. And this is chemical level, physics level. It cannot be breached, it cannot be bypassed. At that point, you will reach what we call a ceiling. There is no energy, and you cannot have a thermal system that runs at 99% efficiency. Like you can push it quite far, but never 99%. And God help you if you are comparing a big ass jumbo jet engine which is hyper efficient meaning touching 50%. Yeah, at that point in time, you need 165% of the energy of liquid hydrogen. That's why you cannot run a giant ass jumbo jet on this. If they directly try to take this 4-cylinder systems, put that basically fuel into one of the engine will turn on, and it's like, okay, we ramp it up and done. Fuel done. Khatam sir, the end. You will run out of fuel. So this is the fundamental core physics level. That's why they are experimenting on a tiny engine rather than this. And be mindful, if you actually try to port this system into that basically passenger jet, business class jumbo jet, that they are not jumbo jet, business class private jet, you have to sacrifice a lot of passenger space, you have to sacrifice a lot of cargo space, like almost all of cargo space. Now here's the deal. If I'm talking about this, what were the engineers? Here's the deal. Entirety of humanity, people who are working with aviation and who are aware of things, we have known this from 1970s. Like this puppy, this is B-57B. This was made, and basically for Air Force, it was a completely successful aircraft, and then they took one of this and used it as an experimental test bed for liquid hydrogen. How old is this? Well, I have provided a video down below. This was done before NASA. Basically, NASA's Papa did this. NASA did this. That's how ancient it is. We did that. It took off from the runway. It switched over, like, again, I told you, hydrogen will run out as soon as you turn it on. So they're like, okay, we take off, you go to high altitude, switch the system. That's why it even had helium purge system. Basically, you had to flush the jet engine. They did all that, and it flew. Everything that it's supposed to do, it did. And the thinking back then was that Air Force was like, hey, we want huge as basically bombers that will go at very high altitude. Now, how do you stay at very high altitude? You have to make a very big ass plane, like U-2 kind of plane. So they scaled U-2 model to large scale, and then they thought, because again, liquid hydrogen is very low density, they knew this. They were like, if you make huge ass plane, maybe it works. That's why they were testing it. This was very, very, very early on, like before even NASA came to be. That's how old this is. And you may be like, okay, Americans could not crack it. Here's the deal. Even Soviet Union tried it, not Russia, Soviet Union tried this. This was a TY-115. This is the first and only, so far, commercial jet that actually had a liquid hydrogen system. Now, the whole back section, that was just liquid hydrogen tank. Did not work. Like, we have done this. And again, this megajoule per liter, this number does not change. It's a fixed system. Meaning liquid hydrogen of basically 1950s is the same as 1960s, same as 1970s, same as 2000, and same as 2100. It will never change. Same goes with jet propellant. Again, jet propellant does go up because, again, as we get better and better and better, the refinement becomes better and better and better, and we remove even a little trace of basically sulfur and all that jazz. So it becomes actually a bit more efficient. But again, roughly it will remain in the same ballpark, so to say. So we have been there, done this. It's like a done deal at this point in time. So why the heck the Boeing engineers are doing it? Why the heck Airbus engineers are doing it? The reality is, you have to understand one core aspect. Again, that's why I said we are people at the end of the day. The engineers who wasted money on basically solar roadway, they knew better than any Tom, Dick and Harry looking from outside. Is like, what the hell you are doing? They knew it better than that, but they were getting paid. So this comes down to one thing: optimism. Meaning, if there is a young engineers like, I want to do this. Maybe they have not aware of this. Again, these are ancient technology, ancient. And again, the video that is from NASA's archive, it does not even have audio. So it's old. Thankfully, it's color, or maybe it's colorized, but it's like very old. So maybe they are not aware of it, that we have done that. Or they are optimistic. They're like, what if I can actually do it? And again, it does make sense at 30% efficiency. It does kind of make sense. And that back in the days, it actually made more sense. Why? 30% is today's engine. Back in their days, the engines were not that efficient. So from their point of view, hydrogen does have the benefit of that it burns very easily. Meaning, if you can make a jet engine, it's kind of easy to scale down the jet engine. Meaning, you can get more thermal efficiency out of it. So if you are actually getting, let's say, 5 or 10 megajoule of useful energy, and you can get the same kind of energy from liquid hydrogen, it kind of made sense. That's why back in those days, it almost made sense. But nowadays, with modern engine, and God help you if you are above 30%, 35%, 40% is like, bro, you have to cross 100%. At 50%, you have to cross 165%. That's why either they are unaware of it, or they are just too hyper optimistic. Now, I do not believe that part, optimistic part. They must know well enough that this will never work. Then why the heck they are working? Here's the come. They are human. They are getting paid. You pay them, they will work on it. It does not matter to them personally. They are like, hey, dude, I have children to feed. I have my wife, child, all that jazz. It's like, I have to, work. I have to get paid, and then so I can take care of them. And you will do the same. I will do the same. That's the whole point. Paid engineers. And then we come to the final layer. Why it's happening now again is law part. Now, this is the most cruel part. If politicians don't understand system holistically, meaning what they are asking, like what will be the consequence, what will be the knock-on effect, quote unquote, they could literally, I want to pass a law and I will pass a law, and because majority of the people have attention deficiency, and again, it's not ill marks towards them. It's not like they are bad or dumb or something like that. It's like, dude, they have life. They have their own things to worry about. So their attention is focused on their life. They can literally miss other things. And that's why we have bureaucrats. That's why we have news channel, hopefully in ideal scenario. But if you are passing a law that we shall not have carbon emission by 2050, what the hell they're going to do? Like, think from that point of view. What other thing can you try? Can you try electric? Hell no. Can you try liquid hydrogen? Hell no. Can you try ammonia? That's useless plus toxic. This is at least just useless. And it does have the benefit of that it looks sexy to people. It's like, oh, sexy. It's like, it's useless, but it looks sexy. So given the constraint of reality that they are facing, it's like, yeah, might as well try to do this. And some people will say, what if we have hydrogen and what if we had fuel cell and then we created electricity, then we run motors? It's like, think about the motor requirement for just jumbo jet engines. Those will be megawatt class motor. Are there motors that are small enough? Yes. Are there motors cheap enough? No. Those motors are what we classify as superconducting motors, meaning it would be idiotically expensive, as in like this will make, the motor alone will make this plane look like bro. That's how expensive that motor would be. And I'm not even talking about the fuel cell stack that you need. Oh, and mind you, all the electrical wiring has to be superconducting. You will go bankrupt. Basically, an aircraft that will cost basically $2 or $3 billion will end up costing 15 billion. That would be the side effect of it. And not to say it will not actually fly. By the time you put that much cryogenics on it, the weight will be like, yeah, barely can do it. And they had to develop special composite alloys and composite substructure to create a tanks for that. Oh, and it also has basically venting, meaning if you put it a runway and you have to stay there for whatever reason, you have to stay there for like few minutes or 1 hour or 2 hours, you have to keep venting of hydrogen in an airport. Yeah, that's one of those things. That's why if any Tom, Dick and Harry tells you was like hydrogen has this many megajoule per kilogram, get a dynamite and be ready. Ask them how much megajoule it has per liter, because you have to carry it in liters. You always have penalty of value. That's why we tried this. Like, this has been done. It's ancient technology. We did this. It just does not work. And I specified, that's why this, pay attention to the percentage part. Once you start to reach that, like, 40% percentage, you have to exceed 100%. And our like, we are trying to get even more out of it, and you can, and like, because okay, it's a linear system, you can actually get even more efficient than 50%. At that point in time, you may be reaching, it's like, yeah, we need hydrogen square something. That's why density matters. That's why all of this is just time waste. We did this. It's like, it's not a new thing. We did that. It does not work. I will give you a real world example. Tata has a lot of trucks that are running on CNG. It does not work that well. Like, they have to keep refilling it. Why? CNG does not have enough energy. So what they do, they switch the CNG to LNG. Basically, gas has low density. How do you replace it? You replace it with liquefied systems that has higher density. That's why, like, if liquid itself, the ultra most dense format you can have, while having some weight limitation, how the hell are you going to surpass it? It's like, if liquid hydrogen barely has 10 megajoule, how the heck your plane is going to fly? So, and if they brute force this sort of system, our tickets will become expensive, and not to mention, over time, your planes will actually go back into terms of technology. They have to become slower, they have to have less capacity, less cargo. Basically, it will become hyper expensive. That's why density matters. Then we come to one hidden aspect of hydrogen that nobody talks about, is like water. There is not that much hydrogen in water. Like, it's common mistake that because it looks like H2O, it feels like, oh, there is twice as much hydrogen as, like, oxygen. But yes, if you compare it mole mass, you're talking about 18. So that's one molecule of water has 18 mole mass. Okay, makes sense. How much is in hydrogen? 2 in hydrogen, because hydrogen is the lightest thing in the periodic table. 16 is from the oxygen. What does that mean? That simply means if you have 1 ton of water, 88% of it is flat out oxygen. Yeah. So there is not that much, hydrogen in basically water. And that's why we do not use electrolysis process to make hydrogen. We use steam reforming of methane. Methane does have higher concentration. So what does this mean? This simply means if you actually want to do this, like this, you smoke full weed and you're like, I'm going to force hydrogen on everybody. You need insanely large amount of deionized water, like very large amount of deionized water. And here's the problem. Deionized water, if you try to make it from sea, God help you, and we do not have enough fresh water. Like, there is no country on this planet at this point in time that has large enough population can say, hey, we have fresh water. Not even so. Like, does not matter France, does not matter India, does not matter USA, does not matter Pakistan. There is not even a single country on this planet that has large enough population and can openly say, we do not have water issue. Flat out. We do not have fresh water, especially for hydrogen extraction, because be mindful, you're going to throw away 88% of it. So flat out, we do not have, like, France literally had to throttle its nuclear plants in year 2022 simply because they were running out of water to cool them. That happened in 2022. In 2022, China suffered a drought that was so bad, the things that they were unexposed, like river bed, became exposed. That was not exposed for 1000 years. I'm not even joking. This is like, summer water supply level in 2019. Looks water. 2021, there is no water. So how the heck in this world where we no longer have water, be it California, be it India, be it China, be it France, be it Germany, how the heck are you going to get the water for that hydrogen? And then somebody's going to smoke weed and they're going to say, we can use, distill seawater. Here's the, why the heck we have not solved these things? Because you cannot distill water cost effectively. You cannot just take ocean and remove salt from it and then have that water. Can it be done? Is there physics? Absolutely. And there we comes to the second important part. Physics, chemistry, basically physics, engineering, economics. Many things make sense in like physics layer, many things make sense in engineering layer. You can make giant ass, RO plants. Does it make economic sense? Hell no. Only OPEC nations can do that because they have surplus of oil and they are just directly burning that oil because again, if you do not have water, there is no point of oil. So they can do it. And even they are like, what is actually kind of pushing it, and they themselves are experimenting on solar dome just so they can do desalination without causing too much damage. And if we brute forces, let's say some Indian politicians like, we're going to force hydrogen on people. Yeah, we're going to do like, but again, the moment you start to do the actual maths, the water scarcity starts to become an issue. So how do you bypass it? I'm going to build, giant as sea desalination system. And consequence of that would be the price, meaning how much you have to pay for 1 liter of basically liquid hydrogen. That will go up. Right now, it's not that expensive because majority of it is coming from methane plants. Basically, at that point in time, just use methane. Just use methane. It's coming from like what we call steam reforming. So if you have to do from electrolysis point of view, yeah, the price will go up exponentially. Can it be done? Physics-wise, yes. Economics-wise, hell no. And that's why I keep saying that go back to goddamn seaweed biofuel. It does all of that without requiring any hassle. And at that scale, the amount of water we need, if you create that much water from any other sources, be it fresh water, be it seawater, the brine you will create, the quantity of brine you create, basically brackish water or wastewater, that will become a hazard to every ecosystem and to us. It's not just like, oh, it's going to destroy ecosystem. If that much drinking water is put into a river, that whole area would be salted. Salted, meaning you will not have agriculture at that area. That's the amount of brine that we are talking about. If that much brine is dumped into the sea, yeah, that area where you are dumping that brine, that area will become sterilized. Not sterilized as in like there is no molecule, there is no life there. It's just like all the native lifespan, poof, gone. Has happened. They're already starting to happen in like OPEC sort of system. So if you keep going, like I'm just going to go yellow on it, there is penalty, like serious expensive penalties. And then we come to the real world. I have talked about the amount. Let's give the numbers to that amount. India alone, 80 billion liters of diesel, 38 billion liters of petrol, 10 billion liters of jet propellant. So these are billion liters. You can check it from India's own websites, as in like governmental website, and there are some other websites also. You can double check this information, and number will fluctuate a little bit up and here. Some years it's a bit less, some year a bit more or less. This is the rough idea. So you are talking about around 128 billion liter grand total. Now let's say you are, hey, I'm gonna switch everything. Again, that's the whole point. You have to switch everything from hydrocarbon to liquid hydrogen. You did that. So let's take 128 billion liters of liquid hydrogen. How much does it weigh? So it weighs around 9 million tons. Does not sound that bad until you realize that translates to 82 million tons of water. Yeah, 82 million tons of water. And I'm being hyper optimistic here. That's a lot of water. How much water is that? 82 million tons of water. How much is that? That's 82 million cubic meters of water. Because again, water was used as a SI unit, so it translates very well from ton to cubic meters. 82 million cubic meters of water annually. That's just for India. Where the heck are you going to get that much fresh water? And to give you context to that number, 82 million cubic meters, Delhi, capital of India, consumes 4.3 million cubic meters of basically water per day. Oh, by the way, you may think India has a high population. All other countries, all capitals, all of them, majority generally consume this level or higher than this. Yeah. And we are having shortage in all the places. Be it California, be it Delhi, be it Mumbai, be it anywhere. Every place during summer or sometimes flat out throughout year, they are suffering water shortages. And in that world, you're going to open your mouth and say, somehow give me 82 million cubic meters of water. It's like, please, I really want to meet that wheat supply. It's like nobody's talking about it. It's like how much? 88%, bro. You have to throw 88% of the water. And again, that itself will become another hassle. What the hell are you going to do with that much oxygen? Like throwing it away is just, it will feel wasteful. I can think one use, you can use it in waste plant incineration. If you put that much oxygen in there, you may get like very, very, very good combustion. Maybe. But that's the issue. Where the heck are you going to get water? Like we have water shortage and I'm going to do this. It's like we can't desalinate water for drinking purposes, which is the core reason. Like everybody will value drinking water more than they value petrol. And somehow you're like, water. That's the hidden part of it. It's like, where the heck you gonna get water from? And not to mention, realistically, you need 3x. So this number will multiply by 3, multiply everything by 3, and then look at me. And again, I would urge you to do this mathematics yourself. If I am off by some digit or some calculation is off, please, I would urge you to write it down below. Please show all your maths. I did that. That's what I'm saying. That's why India's consumption is that high. And again, diesel is like 3x, almost 4x more powerful. Jet propellant is less because diesel is higher, as in like energy density. Kerosene is above that. The lightest energy density is petrol. So the most chance you have in order to switch from A to B is petrol wise. But again, that jet propellant is not gonna go very far. Diesel, hell no. So if you're like, we're gonna have trucks of running on liquid hydrogen, yeah, no. The trucks will be hyper expensive and they will require constant refilling. So in case of India, India has around 60,000 fuel stations. That had to be multiplied by 2 or 3 times because again, none of the trucks will go very far. Again, you can refill them, but again, they will not go very far. Even with liquid hydrogen. They barely go far enough in LNG. So God help you. That is methane. Liquid methane cannot carry your trucks very far. So how the heck you gonna do that on liquid hydrogen? Or even compressed hydrogen, 600 bar, that is the standard. Cars, barely. Because again, petrol is not that dense. So maybe you can do that on petrol. But that's the whole point. Where the heck you gonna get the water from? So let's talk about the other vector of it. Somehow you are gonna magically create that much water, and so here's another vector of it. That's the hidden vector. Second vector is energy. So renewable energies are less damaging than any fossil fuel system that we have. And wind energy, as in like the CO2 emission per unit of electricity of wind, is actually lower than even nuclear. So let that sink in. It has surpassed nuclear because again, we are making huge puppies. Some of these puppies are like around 10 plus megawatt. One turbine, 10 plus megawatt. So renewables are less damaging. That's absolute fact, but they are not harmless. What does that mean? That simply means we cannot just go YOLO on it. And there is always secondary consequences, meaning if you go complete bonkers on it, like if we start to create enough renewables for world energy demand, that's not that much renewable. The moment you had to create liquid fuel out of that much, now that energy consumption goes exponentially. Like try to figure out how much energy is there in, even if you are only converting, let's say 30% of it, how much energy is there in like 100 billion liters of liquid hydrocarbon. Take whatever hydrocarbon, take petrol, the worst one, take how much, that and figure out how much oomph does that mean. So you have to create that much energy. That's exponential. That's assuming you are getting 100% of which you won't. At best, the round trip efficiency would be like, again, battery systems are very good at around 85 to 90%. Hydrogen system, you would be lucky to get 75%, realistically 50 to 55%. So what does that mean? That simply means we cannot just keep scaling solar farms up. We cannot just keep scaling, putting wind farms up uncalled for. Basically, we have to be mindful with it. If we are using it wisely, no consequence. If we do not think about it and we're just scaling it up, because again, we are creating a stupid thing where it's like, we have to create liquid fuel out of it. It's like, yeah, at that point in time, the consequences of these things will overwhelm. How the heck? For example, you have solar farm. You start to mass produce solar farm. What the hell you consume? You consume materials, minerals. And if again, you have that kind of demand, first people will try to do is like cheat. They're like, hey, we are contaminating your groundwater, but we're gonna hide it or do it some other country. That's why I said out of sight, out of mind. Just because you won't see it does not mean it's not there. And over time, it will come back to bite you. So it's one of those things that you have to be very mindful of that. Is solar and wind harmless? Hell no. Are they better option than basically fossil fuel? Undeniably so. And again, here 2022 proved amazingly that you can actually run a very significant portion of a country on basically renewable alone. Because again, European Union as a whole reached a point where they had 22% energy mix for whole year. That's awesome. Like that just in the last 20 years. And that year 2022, they performed so amazingly well that I'm pretty sure over like just 5 to 10 years, that number could touch as high as 30%. And of course, over time, they had to, again, right now they made the decision to remove Russian gas. Slowly over time, they will be like, hey, let's remove fossil fuel. So OPEC also loses power. So that's a very awesome thing. But again, if you overstep your boundaries and use dumb things, there is penalty for that. And solar and wind are not free. How the heck people talk about like, we're going to have hydrogen from renewables. It's like, when did renewable become so free that you can just surplus it? It never became that, nor it will ever become that. Because again, material, it takes engineering, it takes a lot of logistics to just make wind farms. And it takes insanely large amount of logistics to make solar panels. So how much hydrogen you can actually get? So if you have 1 square kilometer, like somebody gave you, here's a area, desert area preferably, 1 square kilometer, how much you can get out of it? You are talking about around 4.7 tons. Not that much. and water wise you are looking at least 53 tons. Be mindful, no electrolyzer is 100% efficient. I have looked into the spec sheet of multiple electrolyzer. Most of them are like, dude, we're not going to give you 100%. Again, it does make sense. You're never going to have like 100% conversion efficiency. So I used I don't know what this European name is, Thunskio unit. That's 20 megawatt unit. That's an electrolyzer unit. So I took two solar farms that are close to basically my own location, as in like equators close. One is 1.6 gigawatt, one is 2.2 gigawatt, one is 37 square kilometers, another is 57. So I divided that and got the like megawatt per square kilometer. Then I multiplied with time, as in like generally they're supposed to work full power for 6 hours. That give me the basically units megawatt hour that you're gonna get in one day. Run that to the electrolyzer units, and then we came up to this number 4.7. Now this is hyper optimistic because I have not calculated the energy requirement of liquefaction, transportation, water pumping and deionizing. At that point in time, that 4.7 could drop as low as 3 ton is not enough. Not, we need 9 million tons, 3 tons per basically per square kilometer. And not to mention, where the heck you're going to get water from? That's the always, because again, if you have fresh water and you are desalinating it, that's a less stressful compared to like directly taking sea water and making it completely deionized. That's a whole different level of power consumption. So that will directly affect it. So that number could drop very low. At that point in time, it's like how much surface area you have. Like, that's not enough. Even Sahara Desert would barely able to do that. And that's why I keep going back to seaweed biofuel. It has water problem solved. It has energy problem solved. All we have to do is cycle the nature properly, efficiently. Thankfully, we have learned it the hard way. We have learned it farming on the land, that if we do not take care of the land, land bitch slaps us. So we have learned it. We have to just put that logic there. And again, fisheries are also doing it. They are cycling their area. So fishes have good, healthy microbe, and they are growing exponentially without harming the ecosystem. We have learned it. Seaweed is far more practical, and whole ecosystem is already built. It's just hydrocarbon. Rather than being fossil, it's bio. Rather than being from the past, it's from the solar. And we do have surface area where we can scale it up. On the sea, most players have the area, surface area needed for this. That's the whole point. Where the heck are you going to get that much money from? Where you can just solar it up, just wind it up. Where would you do that? Like, who will pay for it? You will, actually. So then we come to the penalty side of it. If people are actually that stupid where they are brute forcing hydrogen, that creates a very serious paradox. Poor tech and implementation has severe penalty for common people, not for rich people, not for dumb people who are forcing it, not for bureaucrats, but for you and me. Our cost of living will go up. Meaning, if India has, let's say, 100 rupee diesel right now, at this point in time, 100 rupee diesel to move a truck. So let's say a truck consumes a few hundred liters of it to carry crops from A to B. So that's an X amount of energy cost on the crops itself. It's like, again, crops are useless if you're not going to ship it. So somebody has to consume it. So that creates a certain load. Basically, that's why if fuel prices goes up, food prices follow back very quickly, simply because food had to be transported. Now you replace 100 rupee petrol or diesel with, let's say, 400 rupee liquid hydrogen or hydrogen, just hydrogen. Yeah, we have to pay. Our food prices will go up exponentially, and that will hurt poor far more than anything else. That's the brutal aspect. And people are like, oh, seaweed is expensive. Seaweed is expensive because people are not investing in it. Once you start investing in it, it will go down. Same way solar went down. Solar started like 100 rupees for, like basically you had to spend hundreds of dollars for 1 unit watt of electricity. Now we have like few cents per unit of electricity. Back in the days, we had solar like long ago. Like satellites have been using solar panels long ago. It never had the investment. Once it got the investment, price came down. Why? The logic was sound. Same with seaweed. Is there sea? Yeah. Is there a potential to grow there? Yes. Do we need some macronutrients? Absolutely. Do we need insanely large amount of it? Hell no. No. So that's the whole thing. It can be scaled up. It can be, and everything about processing already there. Vegetable oil is basically lipid to oil extraction, and from oil to hydrocarbon, like fuel grade hydrocarbon, we also have that plant also. It's like everything is pre-built. And again, it takes energy from sun. We don't have to build solar farm for it. It takes water directly from the sea. We do not have to provide water and create a consequence of brine. So that's why it will just brute force it. And the reason liquid hydrogen is not that expensive right now, it's coming from methane. Basically, they're creating emission at this point in time. So cost of living will go up. And if you really are stupid, like let's say some bureaucrats are like, we're going to ban basically farming, and rather than switching farming from, let's say, toxin-based to organic, you have to do it slowly, brick by brick, day by day. But if you're like Sri Lanka and you're like, we're going to do this. And it's like you force it and everybody's like clapping because, hey, organic, awesome. And then the food prices goes exponentially up. Why? Because you literally lost half of the crops. Your food production went down half, price went up exponentially, people suffered. This happened. It's past tense. It's not something that I'm talking about in future. It happened. Same in Pakistan. So you have to understand, cost of living can go up. Like that's the least of your worry, because if it's done out of hand or out of control, it could cause bankruptcy of a nation. Like you can literally take a country like Japan and be like, what the hell happened to Japan? Yeah, it died. Why? They did stupid technology. So you have to understand that. It's very, very necessary for all of us to think about every technology that has been implemented by government, all the holistic system analysis of it. Out of sight, out of mind, we do not have that luxury. And many government can trick you by saying subsidies. It's like, we're going to subsidize it. Here's the subsidy is just tax money. It's not magic. It's your tax. You are paying it. And if they cannot increase the tax, which again, be mindful, European Union cannot tax their citizen anymore. If they do that, people will simply stop making money. As like we have reached a point. There is a limit how much tax you can do. It's generally said to be optimum around 30 to 35%. If you force it to 60%, again, corporate level is different. I'm talking individual level. You force it that way, people will stop making money. And it has happened in the past. Over taxation literally cost serious level of deficiencies. Same thing is happening with Pakistan right now. So what do this government will do? The government will like, hey, if we cut a budget, basically defense cost, people are like, they start writing. So what if we cut education sector? Nobody cares. Nobody is educated enough. What about medical sector? Nobody cares. They will cut those things. You will suffer. So it's one of those things. Subsidies is just your tax money. Subsidy should be there to start something. Like, solar technology got subsidized to start. It was not like, oh, the more we make it, the more miserable it will get. It's not like hydrogen. Hydrogen is like, oh, you build a small plant, it works awesome. Here's the deal, scale it up. Scale it up to the consumption requirement of the country. Then the water becomes a problem. At that point in time, the price goes up. At the small scale, it will always work. Everybody's like, yeah, it works. Some people are giving me example of some tiny nations in Europe in doing it. It's like, dude, their population is so tiny. I live in a neighborhood that has more people than that. It's like, that's why I keep saying, put population in context. That's why top from 0 to 10, like top population countries, see which has like, whatever. Like we have 60,000, 70,000 people in one area, and it's like, we don't have water prices. Of course, you don't have water issues. You don't have people. So subsidies is your money that you have to be mindful of that. And money and time once wasted, it will never come back. For example, all the people in India who smoked weed and did this basically hyperloop system, that money, what happened to that money? That money is gone. It's never going to come back. The company that was actually stupid enough to try that, be mindful, the engineers working there, they knew better than me, that this will never work. But why they were working? They were getting paid. They were like, dude, I'm getting salary. And what happened afterwards? Layoffs. We're going to lay off 50% of the staff. We're going to stop working on basically human-rated hyperloops. I'm like, human are willing to pay basically a lot of money in tickets simply because our time matters so much. They are saying we're going to switch to cargo. Which cargo in this world has that kind of priority? Like which cargo in this world? At that kind of price, it will be cheaper to just have a helicopter with long range. So that's the whole thing. Same with Space Shuttle. The engineers working on Space Shuttle knew Space Shuttle is a bad design. Many of them actually wanted to pursue Saturn V, basically mass produce Saturn V, reduce its cost. But they were forced to work on basically shuttle. And when first shuttle went boom, a lot of investigation was done. And engineering team, like administration was like, this is 1 in a million kind of thing. Engineering team was like, dude, you will be lucky to get 1 in 200. After the second incident, the mathematics was that 1 into 200. As in like most likely one thing will go bad in 100 launches, which it did. So it's one of those things. You and I suffer from it. And that's why USA went from a country that went to the moon to Russia, can you please send our astronaut? Like thankfully now we have SpaceX, but back then they had nothing. So this is one thing. And same goes for solar roadway in India. The amount of money the US government energy department wasted is $1 billion. Like $1 billion is 1 gigawatt solar farm. They could have just built 1 gigawatt solar farm anywhere on the map, and that much energy would have been sold. And again, there is a return on investment on it. We know how quickly it happens. It's like 7 to 8 years, meaning you would have gotten all your money. Let's say extra bureaucracy and blah, blah, blah. Let's say 10 years. You still have 10 years of active life left afterwards. They were like, I spent the money, I got the money back, again, in terms of electricity, sold to the grid, and then I have 10 years of continuous profit. Instead of that, solar roadway. Again, this happened in India. It personally boils my blood. It's like, what were you smoking? And again, the engineers who are forced to build this, they know it. They're like, you're going to talk to them. It's like, oh, you want to put a glass on a ceramic substrate and somehow this glass has to withstand tire wheels? I mean, like with vehicles moving on a like parking lot or like somewhere like actual traffic. Yeah, no, please stop smoking weed. This will never work. This never could have worked. But again, engineers were getting paid. They built it. You were wasting money on it. You are the stupid one. This happened. in my country. Again, if this much money, if they had spent, it's like, hey, railway have giant terminals, what if you put on top of it money, return on investment? What if railway is a different department? What if you put on parking lots? Cars are cooler. Awesome. People are happy. Cars are protected from dust, rain, and all the rest. People are happy. You get electricity. Everybody is happy. Put it on basically stadiums, stadium roofs. You have access to that. Put it on public libraries, roofs. You have a lot of places where you can just get that rooftop, get the energy out of it. Everybody is happy. And they could have showed us, like, what happened to the money you consumed? Oh, here's the return on investment. Or it's like, wait 5 years, the return on investment will happen. This, yeah, they built it and then they tore it down. Money. So that's one thing. Be it Hyperloop, be it a solar roadway, be it space shuttle. Do not ever go into that as like engineers knew this. Engineers, again, if you pay them, they will work on it. So be very mindful. That's why do the math yourself. So this was my presentation on hidden truths of hydrogen. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.